Last week, Ukraine launched a series of attacks aimed at Saint Petersburg, Vladimir Putin's hometown, and the second most politically important city in Russia. The attack was specifically timed to coincide with the 29th annual Saint Petersburg International Economic Forum, which is often described as the Russian Davos. Basically, you had a bunch of folks from Russia's side of the world at war meeting in St. Petersburg to discuss economic opportunities, and Ukraine decided that the backdrop of burning oil installations would make this year's summit especially memorable. But on today's edition of the Geopolitics Helpline, we dive into a very specific strategic aspect of the attack. You have previously talked about how a defender should distribute its resources to make the attacker ambivalent about which target it should strike. Ukraine recently attacked a naval ammo storage facility near St. Petersburg, which I am told primarily held naval mines and torpedoes. Ukraine does not much care about how many mines and torpedoes Russia has in the Baltic. I presume that the attack primarily benefits Ukraine by forcing Russia, who does care, to reallocate defenses, and that replacing these munitions will divert resources that otherwise might make munitions aimed directly at Ukraine. How does the game theory of allocating defenses account for when the attacker and defender place different values on the assets to be defended? Well, the short answer is that the attacker's valuation is just about all that matters for the defensive allocation, even though it's the defender making the allocation, not the attacker. The longer answer is that the viewer is referencing a defensive algorithm that I often discuss, which originated from a paper by Robert Powell. Bob was one of the two people who did most of the early foundational work on crisis bargaining theory. And as the viewer's question describes, the main lesson from that paper is that defenders should allocate their resources to make their opponents indifferent among the various possible places to attack. The second half of the context is that Ukraine did indeed strike the Kronstadt naval base, the home of the Russian Baltic Fleet. You might be most familiar with it from the annual naval parade that Putin loves to attend. But also, as the viewer indicates, there is a bit of an asymmetry in the attack. Certainly, there is a zero-sum element to it, where Ukraine destroying Russian property makes Ukraine happy and Russia sad. However, as compared to striking, say, the Black Sea Fleet, there is an extra bit of disutility that Russia incurs when Ukraine strikes St. Petersburg. The viewer described this in the context of having to pay to redistribute Baltic munitions, but we could point to the public embarrassment from the Economic Forum as well. Okay, how does that affect the defensive choice? Let's think more about how this interaction works. Imagine that there are two targets that Ukraine could strike, location A and location B. Meanwhile, Russia has a set of defensive assets that it must divide between the two locations. Central to the whole strategic dilemma is that Russia must move first. Ukraine can see where Russia has placed its defensive assets, and then Ukraine finally decides which place to strike. At the risk of mathing this to oblivion, but then again, you are on a secondary channel of a mathematical PhD professor, so I suppose this one's on you. Russia begins the interaction by allocating a percentage of those defensive assets to location A. We will call that percentage D sub A, with the 0 and 1 here representing how it is indeed a percentage. Choosing 0 means no defenses for A, while choosing 1 means all of the defenses for A. The remainder, which works out to 1 minus DA, is what protects location B. After seeing those allocations, Ukraine attacks A, or Ukraine attacks B. If Ukraine attacks A, we have a purely zero-sum relationship. The lowercase a here is a function that maps a defensive allocation to location A to an amount of damage incurred. Note that this is not A multiplied by D, and we can curse whichever mathematical god decided that functions and multiplication should have identical representations. Again, this is a function. Anyway, the top line is how much Russia loses as a consequence of the attack, and the second line is how much Ukraine gains from the attack. One is the negative of the other, so whatever Russia loses is what Ukraine gains. As you would expect, the function decreases in dA. In other words, conditional on striking location A, less damage is done the more that Russia protected it. Over on the other side, we have a similar story. There is a zero-sum segment of the payoffs, now represented by the function B. Recall that dA is the percentage of defensive resources allocated to location A, So 1 minus that quantity is the percentage of defensive resources allocated to location B. The function increases in dA, intuitively meaning that location B becomes more vulnerable as Russia assigns more defensive effort to location A. The extra kink here is that we are also subtracting C from Russia's payoff in the event that Ukraine attacks location B. Note that this reflects whatever Ukraine does not care about. It is the extra loss that the defender faces over and beyond the zero-sum military or political value of the attack. Well, Ukraine has an advantage here in that it moves last and has observed how Russia has distributed its defenses. And that makes its decision straightforward. For a given value of dA, Ukraine attacks A if A of dA is greater than B of 1 minus dA. Ukraine attacks B if A of dA is less than B of 1 minus dA. And Ukraine is indifferent when those values equal each other. A visualization will help us understand the next step. These are example payoffs for Ukraine as a function of dA. The A function decreases in dA, and the B function increases in dA. Outside of trivial cases where one site is way more vulnerable than the other, some value of dA makes the two functions equal. Note that this is an application of the intermediate value theorem, something that you probably learned about in 9th grade and immediately forgot about because it seemed to have no practical value. Volodymyr Zelensky begs to disagree. Anyway, Ukraine attacks A when Russia's chosen effort level is less than the intersection cut point, and Ukraine attacks B when Russia's chosen effort is greater than the intersection cut point. Note that the personal loss Russia suffers from one particular site being attacked has nothing to do with Ukraine's choice. This may seem strange at first, but keep in mind that this is definitionally true. Whatever extent Ukraine cares about Russia's losses is already wrapped up in the B function. The extra cost is defined as the extra amount that Ukraine does not care about. Now think about Russia's payoff for any chosen value of dA, holding fixed an attack on location A. Unlike Ukraine, its payoff increases in dA. Meanwhile, Russia's payoff for any chosen value of dA holding fixed an attack on location B decreases in dA, again in contrast to Ukraine. It is also set a little bit further down than Ukraine's payoff because of the extra loss of the C value. However, the key thing to realize is that, in practice, the location of the attack is not held fixed in dA. We know from before exactly how Ukraine responds to any specific allocation. When dA is small, Russia receives the value associated with the attack on location A. When dA is large, Russia receives the value associated with the attack on location B. Russia's induced payoff function therefore looks like this. In turn, the game that the policymakers in the Kremlin are playing is to choose the value of dA that maximizes their payoff, conditional on Ukraine's strategic response. Now, as I have been describing this, we have been treating dA as a completely continuous variable, which is fine for mathematical tractability. You can indeed get pretty fine-grained in how you allocate defenses. But in practice, if there are any small rigidities in the values of dA that Russia can choose, then it should pick the dA value closest to where the cut point is, but just to the left of it. Basically, do just enough to convince Ukraine to attack the location where Russia is not facing the extra loss. Okay, that is the theory. Let's get to the application. Before discussing Saint Petersburg, I should note that this prediction sometimes matches what we observe, and can be helpful for understanding the logic driving wartime decisions. Every year, we get an annual media frenzy about the Kremlin's Victory Day parade, and how it is a prime target for Ukraine to attack. Yet, as of 2026, Ukraine has left it alone. And sure, there is a huge amount of zero-sum dynamics regarding the event. But it is also reasonable to think that there is an extra loss for Russia associated with it being the target. Red Square is a landmark that has historical value aside from whatever is happening in the war. Well, contrary to those media hot takes that always insist that the Victory Day parade will be struck, what we just saw helps explain what routinely happens. Russia wants to put just enough defense into it to push Ukraine to strike the other thing. However, Saint Petersburg last week did not match the same prediction. I can offer a couple of explanations as to why. One, it is possible that the original question makes an incorrect assumption. There may be some extraneous costs associated with attacking the Baltic, but there may also be some extraneous costs associated with attacking the Black Sea instead, say international grain exports. If there are cost losses at both locations, what ends up mattering is which location has the bigger cost. Argue among yourselves which is the one that wins that award. 2, and I suspect much easier to justify, is that both Russia and Ukraine are not exactly sure about the opposing offensive and defensive capabilities. What we just worked through was the simplified vacuum where everyone knows everything about everyone else, which helps us learn an important strategic lesson. Just like in physics, that is what a vacuum is for. Outside of our helpful vacuum, though, it is not hard to see how uncertainty could lead to a more nebulous prediction. For example, if Russia does not know Ukraine's capacity, and therefore cannot exactly pinpoint the break-even defensive allocation, you run into a bit of a risk-return trade-off. Here, pushing more defensive resources to protect the more vulnerable location ensures that Ukraine wants to attack the other location. But the more that you guarantee the vulnerable location's safety, the more likely that Ukraine is to strike the ironically increasingly vulnerable other location. Like other situations with uncertainty in international relations, predicting which way things will go is not possible for us as keyboard warriors. If we knew what Ukraine's capabilities were on this front, then Russia ought to know as well, and the assumed uncertainty does not actually exist. Instead, we are left to only provide higher-level analysis of how the trade-off works. I should note that Robert Powell worked on these sorts of models with uncertainty, so it is not like we are clueless about how they work. But they are a lot more complicated, and they go a bit above what today's question wanted to examine. Perhaps another time. And that means our current time together is over, but there is still a rapidly growing playlist of other geopolitics helpline videos for you to explore. And if you enjoyed today's video, then please like, share, and subscribe, and I will see you tomorrow. Take care.